Yeah, thanks, Julian. Okay, here we go. So, 210. Keegan's birthday is tomorrow, by the way. 210. 23. So our objective today is going to be graphing parabolas. So again, every time you see the word quadratics, they really mean some x squared, okay? But graphing parabolas, which is the word for graphing the graphs, okay? So before I even start on the first one, let's just write this. Y equals a x minus h squared plus k. That is vertex form. Hopefully you remember that. You have seen this. You saw this in Algebra 2, okay? That is the form for vertex form. Now there's a couple of things that's nice. We know the vertex, no matter what, in this is hk, the value of hk, okay? And because of the negative here, it's always the opposite, right? And I'll let you catch up, okay? That's our vertex form. Whatever numbers are here and here, that's my vertex, if it's in this form, okay? So, in math, the negative means opposite. So whatever the h value is, we take the opposite of it, okay? So, you ready for me to start on this problem, or am I going too fast?
Go ahead.
Lexi, am I good?
I think so.
So first of all, the line of symmetry is just simply going to be x equals the h value. So that's it. The line of symmetry is just x equals h value. In this case, it is going to be x equals negative 2, okay? Negative 2. So the line of symmetry is simply a line that goes down through the middle, which means it has to go through the vertex. So at negative 2, I just like to draw it in. It's not really part of the graph. It's really an invisible kind of boundary line. But it gives me symmetry, right? We know what the vertex is because it's in vertex form. So my vertex has to be at negative 2, comma, positive 5. So I can go to negative 2, positive 5, 1, 2, 3, 4, 5. And there's my vertex. Now the a value tells me some things also. The a value tells me a lot of things. It tells me whether it's a stretch or a shrink. It also tells me in this case whether there's a reflection. If a is less than 0, then it has to be a reflection over the x-axis, which is what we have, right? We have in this case a is equal to negative 2. And I will slow down for you, Lexi, and let you catch up, okay? So I know it's a frowny face. I'll just call it a frowny face. It's so mathematical. Call it a frowny face. I know it's going to be upside down. There's two ways to graph it. And I want to show you the more mathematical way because sometimes it's difficult to get values. But the best way, really, is we can go straight for the y-intercept, okay? I know my parabola is upside down, and it's a vertical stretch of 2, okay? If I can get the y-intercept, then I get a third point, okay? So the y-intercept is when we know we let x equal 0, okay? If x is 0, we get y. If x is 0, we get y, okay? Slide that up. So I would do this. To find the y-intercept, I would take y equals negative 2 times 0 plus 2 squared plus 5, okay? That's going to give me the y-intercept. It's not 5. You would think it's 5, but because of its form, 5 is part of the vertex, not the y-intercept. The 5 is part of the vertex, not the y-intercept. But if x is 0, I'm going to figure it out, okay? So I get y equals a negative 2 times a 2 squared plus 5, right? I just went 0 plus 2. That's all I did. I'll square 2 and I get 4 times negative 2, I get a negative 8 plus 5. So finally I get y equals negative 3. So my y-intercept is at 0, negative 3. All right, I can graph that too. That's easy. And once you get that, you have a third point. Everybody agree? Can you see the third point right here? Everybody see that third point? Everybody agree with that? Has to be because of symmetry. And I could draw them in. Now, the only thing I don't have are the x-intercepts, right? So how do I find the x-intercepts? Okay. So you let y equal 0, okay? So to find x-intercepts, we're going to let y equal 0. All right, let's see if I can squeeze this in. I will have 0 equals negative 2 times x plus 2 squared minus 5, okay? I just let y equal 0 to find the x-intercepts. Thank you. I would have had an I, wouldn't I?
Yep, you are.
But I don't. I won't have an I now. Yes.
Oh, there you go.
Yes. I know. I hate it when I make mistakes. Glad you guys are here. So then, step 1, bring over the 5, and then it is negative 5. Haha, I finally got my negative 5 in there, didn't I? Right? Divide by 2, and I'll get 2.5 equals x plus 2 squared. I just divided by negative 2. I just skipped that step. We're in pre-calc, but you okay? Divide by negative 2, divide by negative 2, right? Square root, how many answers? Has to be 2 answers, because how many x-intercepts do you think we're going to have? Pretty obvious there has to be 2, right? So then, square root of 2.5, what is that, a 1.25? 1.5?
Would it be 1.5, 0.5,
Yes, it's going to be a 0.5, right? Yeah, it's got to be. Well, hold on. I think the decimal's going to mess us up. Yeah, it's not. I thought that decimal was going to mess us up, Charles. I'm like, wait a minute. If it was a 0.25, I'd agree with you, but it's not. So it's about a 1.6 plus or minus 1.6. And this is where we want to use decimals because we're going to graph it. Make sense? This is where we want to use decimals because we're going to graph it. And I always round to the nearest tenth because that's the most accurate I can graph, right? So then I'll have a negative 1.6 equals x plus 2, and I'll have a positive 1.6 equals an x plus 2. I'm just taking... Yeah, thank you. My bad. Okay, and so I just brought this up over there. So if I solve, I'll get x equals negative 3.6. And I'll get x equals a negative 0.4, right?
Yep.
Okay. I don't know, negative 2 plus 1.6. It's all good. Always question what I do. Will you please always question what I do? But I'm right this time. Ha! Okay, so those are my x-intercepts, and I can write those as a 1.60 and as a negative 0.40. I'm going to highlight that. I'm just going to highlight all the important stuff, right? So there's my x-intercepts. I can go back to my graph. I can put those in there. I've got my y-intercept. I've got my line of symmetry is there. I've got my vertex there. And so when I put in my negative 0.4, it's about there. And negative 1.6, it's about, hold on.
Negative 0.6 to negative 3.2.
Negative 3.2, thank you. Thank you. That should be a negative 3.2. All right, I knew something right. There we go. Thanks, Anna. Man. I was like, something didn't look right, and there it is. I can graph it. Yes.
The negative 1.6
Here, I'll put it up here, okay?
to the 3.6.
Okay, you guys see it? I wrote down the right answer, but I put it wrong up here. I just wrote down the wrong thing. I was getting too sloppy. That's why neatness helps, okay? Okay, thumbs up, everybody. Okay, I'll wait for you. Anna, question?
No.
You sure? All right. Okay, turn the page. Okay, so here we go. Example 2. So example 2 is in what we call intercept form. So this is intercept form. It's already been factored, right? Those were already mini equations, correct? So the cool part is that we can get the x-intercepts pretty easily. So we set it equal to 0. So I may as well go straight for the intercepts. I mean, it's already in factored form. I already have my mini equations, right? I mean, it's already factored. I don't need the negative 2. The negative 2 does not affect the intercepts. It just affects the stretch. So one x-intercept is negative 4. The other intercept is 2. So we've got negative 4, 0, and 2, 0. Okay, everybody good on that? I just did my mini equations. So I'm going to graph those at 1, 2, 3, 4, and 1, 2. Now, because a parabola is symmetrical, I know the line of symmetry is right. It's got to be right there because it's in the middle, correct? It's right down the middle. So my line of symmetry is just the average, so I know my line of symmetry is at x equals negative 1, okay? Well, that's great. I can get its y value by plugging that in. Okay, so I've got x equals negative 1, ever get that? So then the vertex, to find that, let's plug the negative 1 in. Okay, plug in x equals negative 1, because the vertex has to lie on the line of symmetry. It's got to be somewhere here. So I plug that in. Okay, I'll go y equals negative 2 times a negative 1 plus 4, negative 1 minus 2, and I'll find the corresponding y value, okay? So I'm going to have y equals, let's see, negative 2 times 3 times negative 3, which is a negative 8, positive 18. So my vertex is at, nope, negative 1, my bad, negative 1, 18. All right, way up there. I'm going to have to go by 2s or something, aren't I? 6, 8, 10. Nope, I'm going to have to go maybe by 5s. 5, 10, 15, 20. So it's about there, okay? And then the y-intercept is pretty easy. The y-intercept is if x is 0, right? I have to squeeze. I'm running out of room. I'll squeeze this up here, okay? Okay, the y-intercept, I should give them my y-intercept. Let x equal 0. So I'd have y equals a negative 2 times a 0 plus 4 times a 0 minus 2. Let's see. Negative 2 times 4 times negative 2 is 16, right? Positive 16. So I'd have a positive 16, which is probably right about there. A lot of mess. I wish I was neater and didn't make mistakes, right? Now, example 3 is the exact same as example 2, except for without the graph, okay? It's just to find the equation, okay? But we want to put it in standard form. So here's what we know, okay? Am I going too fast? I would be so happy to, yes. Haley. Let me give you the. What if my notes? Right here. Okay, and then you can take a copy of my notes when I'm done. All right, Emily, you ready? Now, you don't really need to do a sketch on this. You do know this, that if this were an x-intercept, it came from a mini equation of x minus 3. Okay, all right? If I get an answer of 3, 0, it came from a mini equation of x minus 3. Thumbs up on, does that make sense? Okay? And if I get a 6 as an x-intercept, it came from a mini equation of x minus 6, right? So here's my equation so far. Y equals some a value, which I don't know, but I have to find, x minus 6 times x minus 3. Okay, now, lots of graphs can have those x-intercepts, but we want the exact graph that goes through the point 0, negative 2. Well, let's put this point in to make sure it goes into it, right? So if I put the point 0, negative 2 into my equation, it forces it in, and I get the value of a that works. So I'm going to take and plug my 0 in for x and my negative 2 in for y. I will put my negative 2 here, and I'll put my 0 here and my 0 here, so my equation is going to look like this. So I plugged my 0 in for both x's, and my negative 2 in for the y value, and I just need to find the value of a. So I have negative 2 equals a times positive 18. Okay, you okay with positive 18?
Yeah.
Divide by 18. I reduce that to 1/9. Okay, 1/9's okay, I can live with that. So my answer is this. I get a y equals a negative 1/9 times my x minus 6 times my x minus 3, right? Almost done. I would say I'm done, but then the question says what? You see anything in the question? What do you see? Standard form. Do you see standard form? Well, FOIL, but yeah, FOIL, right? You guys okay with FOIL? So let's fix it. Let's FOIL it. I'm going to leave the negative 1/9 out here for a little bit until I get done FOILing. X squared minus 3x minus 6x plus 18, right? Negative 1/9 times x squared minus 9x plus 18. Okay, I gotta multiply through. Well, this is gonna turn out nice. I like this one. I'm gonna get a negative 1/9 x squared plus a 1x minus a 2. There we go. Okay, that's what I got for you, okay? And the homework is only 5 problems. That's not so bad. And we got lots of time to get it done. Yeah. We can get it done and not have anything to worry about all weekend long. Just chill. Yes. Get this to stop.
Oh.
Stop.